Good morning. I welcome one and all on behalf of the online learning platform at Department of Civil Engineering, BMS Institute of Technology and Management. My name is Dr. Rajesh Gopinath, and we shall be discussing an important topic from the course Water Supply and Treatment Engineering. Last class, we had spoken about coagulation, one of the most important elements or components of a water supply scheme. In today's class, we shall be discussing about filtration. Slide 4. If you look at this slide, we understand that after the preliminary treatment, primary treatment, the water moves on to the filtration unit. And after filtration is completed, it goes on to the subsequent processes of disinfection. Filtration is a critical process because those solids, those particulate matters which has not been removed either by sedimentation or coagulation, those fine dissolved solids or colloidal solids or microorganisms which have not been eliminated in the previous processes, it needs to be eliminated or removed in the process of filtration. Slide 5. Today's presentation will be covered in the following manner. First, we shall have a brief introduction. Further, we shall move on to understand what a granular medium filtration is. Today's core topic remains theory of filtration, its construction, function. Okay. We shall have a brief understanding of operation and maintenance issues in filters. I'll also give you a brief preview of the different type of filters in practice. We shall then move on to summarizing it, and towards the end, I will be listing the references which you can refer for enhanced information. Slide 6. As I told you, filtration is a process which aids in removing those impurities which have not been removed from the operations such as screening, sedimentation, and clarification or clarifoculation. That is basically a coagulation process. Filtration basically can be in two mediums. One is your pre-coat filtration, and the other one which is prevalent in today's scenario, that is your granular medium filtration. Wherein in pre-coat filtration we employ screens. In granular medium filtration we employ filter media such as sand and gravel. Slide 7. There are various mechanisms in which filtration is achieved. It can be vacuum filtration, pressure filtration, biflow filtration, upflow filtration, or downflow filtration. With respect to the curriculum, we shall be discussing downflow filtration, which means the water moves from top to bottom with the aid of gravity. So it is just based on the gravitational force that the water is moving from upside to downside. And all the filters, such as the slow sand filters, rapid sand filters, and pressure filters, are downflow filters. Let's move on to slide 8. Theory of filtration. So how exactly does the filter work? What is the principle behind the operation? How is that these structures which are called as filters are successful in removing impurities or solid particles which the process such as coagulation and sedimentation could not achieve? As you can see in slide 8, there are 4 basic means or 4 basic mechanisms through which the theory of filtration is accomplished: mechanical straining, sedimentation, biological metabolism, and electrolytic action. Let's look at the first one. Let's move on to slide 9. So mechanical straining. let's break up those two words, mechanical and straining. Now, kindly observe the schematic representations on your slide. If we imagine that the water is flowing from top to bottom and this water contains impurities, as this water is passing through sand, okay? Now, obviously, when these particles, the suspended particles, which are bigger in size, try to pass through sand particles, they get stuck. The sand particles do not provide sufficient space for these impurities to pass through. Hence, the sand particles restrain the movement of these impurities. Hence, the movement of the impurities are mechanically strained by the sand particles. The advantage is most of the suspended particles are removed in the upper layer itself. However, we also need to understand that it's only the first few centimeters wherein the major removal takes place. Nevertheless, the entire depth of your filter and the filter bed is of importance. How we shall see further on. Slide 10. Sedimentation. If you recollect, I told you that most of the removal happens in the first few centimeters. Then how is that the following depth below it is helping infiltration to take place? Now let's look at the sketch on your slide. What happens is, as the particles come through the water, as they're trying to pass through the sand, they get stuck in the top layers. Eventually, some of the particles may escape the sand particles, the grains of sand in the upper layer, but as it is moving downwards, it may get strained. So it is possible that as the water constantly flows, these particles eventually get stuck in one or the other layer. Eventually what happens is, these particles which are getting stuck between the sand particles, they will not allow any other particles also to pass through them. Eventually they behave like a sedimentation bed. So eventually your filtration, there are multiple sedimentation beds created, mini sedimentation tanks created. Now, the forces which acts upon this mechanism is your random forces such as the Brownian movement and the initial impaction. Let's move further to slide 11. Biological metabolism. As we are aware, the water contains microorganisms. Water may also contain algae. Eventually, the impurities which is present inside the water is actually food for them. So over a period of time, when the water is flowing from top to bottom, the microorganisms get deposited on the top layer of your filter bed. These microorganisms begin to consume these impurities. So eventually it is these microorganisms which remove the impurity by consuming them as their food. However, it may also lead to a problem of dirty skin if in case proper maintenance is not incorporated. Slide 12. The fourth principle or the fourth mechanism of removal of impurities is a very simple logic wherein we consider that the sand particles and the impurities inside the water are carrying opposite charges, and we are very well aware that opposite charges attract each other and hence get neutralized. So by this principle, eventually what happens is those impurities and the sand particles get attracted to each other, thereby the chemical nature of the water gets altered. Let's move on to slide 13. Let's try to understand the construction and the function of filter media. So filter media is that media which is responsible for filtering the water, which is responsible for removing the impurities from the water. Either we can go for a single media or a dual media. If in case you go for a single media, it is the filter sand. And if in case we are going for dual media, it is a combination of silica sand and anthracite coal. Now, what are the properties of a filter media? It is very important that the filter sand or the filter media for that matter should themselves not be carrying any impurities. They must be free from clay, vegetable matter, organic impurities. Also, it is imperative that they are uniform in nature and size. They must be resistant and hard. Okay? Now, generally, the filter media is obtained from hard rocks such as quartz and basalt. When we keep the filter media in hydrochloric acid for 24 hours, it is expected that it shall not lose more than 5% of its weights. This is certain or few of the desirable properties to qualify as a filter media. Slide 14. Base media. If we are imagining a filter, we would imagine water as a top layer. Below the water, we would be having the sand, that's the filter media, and below the sand, we will be having a support that is called base media, and generally the base media is made up of gravel. So what does a base media do? This base media or gravel has important functions to ensure that there is no loss of sand or the filter media itself into the under drainage system. Under drainage system is basically the network of drains which is responsible for collecting the filtered water. The gravel is also responsible to have a smooth movement of water from top to bottom, that is the actual operation of filtration, and also from bottom to top, that is when the filter is being backwashed. Let's move on to slide 15. Let us look at some of the operational problems in a filter. Cracking and clogging of filter bed. Due to high head losses and rapid accumulation of impurities or solids on the top surface, there is possibilities that cracks can be formed due to the vacuum conditions, and when these cracks are formed, then water will eventually pass through without getting filtered. In the similar manner, when the filter gets clogged, then also the water does not pass. So when the water is not passing from top to bottom, when the filtration is not taking place, this actually also increases the head loss. Now when the head loss increases, it leads to cracking. So this is a vicious cycle. Second operational issue, air binding. During the process of filtration, there are releases of dissolved oxygen and certain other gases which eventually forms bubbles, and these bubbles, they occupy those empty spaces or the void spaces in the filter media. Now when these effective spaces are occupied by these, the efficiency of the filter again reduces, leading to negative head, which is loss of head. Third issue, sand incrustation. This basically means change in the effective size of sand. As I told you, filter media or sand has certain uniform properties. If these properties can be altered, then its function also gets altered. This problem typically happens when the water which enters the filter has high dosage of coagulants in them. For instance, lime. When such heavy limed water enters your filters, there is crystallization which takes place of calcium carbonate. As a result, there is more deposition of the sticky flocks and gelatinous materials. This invariably will reduce the space which is actually available or was available for filtration. Let's move on to slide 16. Jetting and sand boils. During the operation of backwash, that is when the water is passed from bottom to top to clean the filter, water by default, whether it falls from top to bottom or bottom to top, it always tends to take that path which offers the least resistance. In this circumstance, when water tends to take that path which has the least resistance, eventually this disturbs the proportioning of the sand and gravel, and actually when the water further is entering for filtration, water will again take the same path. That means filtration doesn't take place. Next issue, sand leakage. This is basically the movement of your fine sand particles, that is your filter media, when they move on or they are lost into your laterals or your main drain. This actually happens when the proportion is disturbed during the operation of backwash. But what does this cause? When your filter media or sand particles escape the base media and enter the drains, they block your drains. Again, thereby the filter efficiency is reduced. Finally, mud balls. If you recollect, when we spoke about biological metabolism, I had told you that the microorganisms, the algae or bacteria, they tend to get deposited on the top layer of the filter which contains impurities, and these impurities are food for them. Okay. Over a period of time, they increase in size, and not just these, also dust particles. When the filters like slow sand filter and rapid sand filter are exposed to atmosphere, it is obvious that dust which is omnipresent in the sky, in the air, in the ambient air, they tend to settle down and fall into the water. Eventually, they grow in size and weight over the time, and these eventually becomes mud balls which sinks into the bed, and they actually clog the filters, which again disrupts your filtration process and also your backwash process. Let's move on further. Slide 17. In the further classes, we shall be discussing about the three different types of filters: slow sand filter, rapid sand filter, and pressure filter. By default, the name itself suggests slow sand filters, those filters which have a very slow rate of filtration. Rapid sand, which has a higher rate of filtration. Pressure filter, that which works under pressure and not under atmospheric pressure like your slow sand and rapid sand. Slide 18. Let us summarize what all we have learned till now. So we have understood that filtration is a critical unit operation in your water supply scheme which enables to remove the impurities, the solid particles which could not be removed by screens, sedimentation basins, and coagulation units. Filtration is achieved by 4 different means, either in combinations or separately: sedimentation, mechanical straining, electrolytic action, and biological metabolism. Finally, there are 3 types of filters: slow sand, rapid sand, and pressure filters. Slide 19. These are certain references which I have gone through while drafting this presentation for you. I would request all of you to go through this and enhance your knowledge. Slide 20. This is how a typical slow sand filter looks, and this is what we will be deliberating in our next class. Slide 21. I thank one and all for your patient hearing. This is Dr. Rajesh Gopinath signing off. Godspeed. Take care.